Hello students. So in this video students we will focus on the ions or radicals. In the previous video we completed the discussion about symbols and the formations and atomicity, all these basic concepts, basic terms and definitions. Now in this video about ions. First of all students, what are ions, like how do they form, when do they form, what are the conditions for their formations, everything we will discuss. So chemical reactions takes place by three ways we discussed in the last video. Chemical reactions takes place in three ways. So what are the three ways students? Chemical reactions takes place when an atom loses electrons, gains electrons and shares electrons. As certain students. So leave this sharing. So what are the first two? Either losing or gaining. So when an atom loses electrons or gains electrons, the resultant particles are called as ions. That means ions are coming from atoms only. Ions are not completely any new substances. Got the clarity students? When do ions form? When an atom loses electrons or gains electrons. The resultant particle, atom only converting into ion. The resultant particle is called as ion. So to define ions, how can we define? Charged particles are called as ions. What are ions students? Simply charged particles. That means when an atom loses its electrons or gains electrons, it will end up with a charge. It will end up with either a positive charge or a negative charge. So that charged particles are called as ions or also radicals. If a compound dissociate, the resultant particle is called as a radical. Both are same. Ions are normal simple elemental ions. Radicals means mostly comes under compound ions, a group of atoms with a charge. So that discussion also we have in this video in the coming examples. So based on the charge, like either positive charge or a negative charge, ions are two types students. One is cation, second one is anion. So when a positively charged particle is called as a cation or a negatively charged particle is called as anion. So when cations form and when anions form, we'll discuss now. Students listen. When an atom loses its electron, when an atom lost its electron, it becomes into a positive ion called as cation, and when an atom gains electron, it becomes into a negative ion called as anion. That's it, very simple. So what are cations, what are anions students? First of all, what are ions? When an atom either loses or gains electrons, becomes into an ion. And in these ions, two types, cations and anions. When cations will form, cations are the positive charge. When an atom lost electron, it becomes into a positive charge. When an atom gains electrons, it becomes into a negative charge. Why? That clarity we'll discuss in this slide. So for example, look at here students, sodium atom. What is the atomic number of sodium? Atomic number is 11. How many electrons are there? In sodium there are 11 electrons. How many protons are there? 11 protons. Yes or no? From this state, sodium, according to the nature of sodium, according to the chemical reactivity of sodium, sodium loses one electron. If it lost that one electron, now how many electrons are remaining? Previously 11 electrons are there in that atomic state. Now how many electrons? Only 10 electrons. Yes or no? One electron is lost. And is there any change in protons? No, there is no change in protons. Now 11 electrons, 11 protons in the atomic state. What is the net charge? Electrons are negative, protons are positive, plus 11 minus 11 equal to 0. Do you find any charge on this sodium atom students? Absolutely no. All atoms are chargeless. Why? Because they contain equal number of protons and electrons. Electrons are negative, protons are positive. That's why positive particles are equal to the negative particles. The net charge is always 0. Atoms are always neutral. But when do they get the charge? When they lose electrons or when they gain electrons. Here sodium is losing 1. Now the electrons becomes 10. So that means how many negative particles are there? Only 10, minus 10. How many positive particles are there? 11 positive particles are there. Now what is the net sum? What is the net charge on this sodium? Plus 11 minus 10. How much? Plus 1. Yes or no? And the resultant particle, how to write? Same, Na plus 1. This is called as sodium ion, which is a cation, which is a positive charge. Got the clarity? Why atoms after losing electrons becomes a positive charge? Why? Because positive particles are dominating more in there than the negative particles. Why? Already lost now. That's why. If an atom loses one electron, it gets a plus 1 charge. If an atom loses 2 electrons, you answer what is the charge it will get? Plus 2 charge. If an atom loses 3 electrons, plus 3 charge, and the same. Now we have one more example in the case of anion students. So chlorine atomic number is 17. Atomic number is 17. How many electrons are there? Obviously 17 electrons. How many protons are there? 17 protons. That means plus 17 minus 17. How much? 0. All atoms are neutral students. But according to the nature of chlorine, chlorine is gaining 1 electron. Chlorine is gaining 1 electron. Now the number of electrons become 18. Yes sir, 1 electron is getting added. Is there any change in protons? No, there is no change in protons. Now which particles are more? Protons are more or electrons are more? Once look at the numbers. Now electrons are more. How many? 1 electron is extra. Yes or no? That means same, minus 18 plus 17. How much? What's the net charge? Net charge will be minus 1, and the resultant radical should be represented like Cl minus 1, which is chloride ion. So here the principal idea behind the ions formation is that when an atom loses electrons, it becomes into a positive charge. When an atom gains electrons, it will get a negative charge, and that charged atoms are called as ions. Simple. Atoms with charge is called as, it is no more called as atom, it is called as ion. With a positive charge, cation. With a negative charge, anion. Plus 1 lost 1 electron. Plus 2 lost 2 electrons. Plus 3 means it lost 3 electrons. Minus 1, minus 2, minus 3 means it lost 1, 2, 3 electrons respectively. Got the clarity, students? And why do they get the positive charge and negative charges? Also clearly we discussed in this slide. So next one we have the types of ions, both cations and anions. Here we have in this slide we have cations are also called as electropositive ions. Students, cations are also called as electropositive, positive charge. Na examples: H plus, Be plus, Al plus 3, lead ion and stibbium. All these you can look at the charges. They have plus 1, plus 2, plus 3, plus 4. All the charges. Ultimately, what is the common thing in all these charges? Positive. That's why they comes under these cations or electropositive ions. So we have the following types. For the first one is called as monovalent electropositive ions. Students, the first type is called as monovalent monovalent. What's the meaning of monovalent? Mono means single, that's it. Valence, its valence is 1. Electropositive, it's a positive. That means the examples, the ions which are having plus 1 charge all comes under monovalent. Look at the examples here. H plus ion, what is the charge? Plus 1. Sodium ion, what is the charge? Plus 1. Rubidium, ammonium, all they have plus 1 charges. Yes or no? That makes monovalent. Now I think remaining all very, very simple. Divalent means divalent or bivalent, both are same. What is the charge they have? Plus 2 charge. Trivalent means plus 3 charge. Tetravalent means plus 4 charge. Pentavalent means plus 5 charge. Got the clarity? It depends upon the type of element. Sir, can we write monovalent ion as trivalent? Like, can we change plus 3? No. We don't do that. We cannot change that. That depends upon electronic configuration in atomic structure topic. And that depends upon octet rule. We'll get in chemical bonding chapter. These are basics. Just remember. Sodium ion means Na plus only. You cannot change to Na plus 2 or Na plus 3. Got the clarity? You have to remember the charges of these particular examples which comes under mono, di, tri and tetra positive ions. So these are some of the examples you can check in the list of cations where all the type of examples: hydrogen ion, lithium, magnesium, mercurous. About variable valency also we discussed in the previous video. So these are the main ions. Like we have 118 elements. Are we writing all these ions? Means no. The ions which are mainly most frequent under the chemical reactions only, we'll study about those particular ions only. You have to remember the name is common, but variable valency names you have to remember. When variable valency, how to remember? The lower valency OUS, higher valency IC. Ferrous ferric, stannous stannic, mercurous mercuric. Yes or no? Cuprous cupric, like that. You have to remember the names and their certain valencies. So these are all the list of cations. So why do we need to remember all these ions? That I will give you the clarity by the end of this video, students. Next, electronegative ions like electropositive. Opposite is electronegative. Yes or no? All these ions have, what is the charge? -1 charge, negative charge. So we have the following types of electronegative ions like monovalent, divalent, trivalent negative ions. Monovalent means what? They have -1 charge. Divalent means what? They have -2 charge. Trivalent means what? They have -3 charge. That means, what is the meaning of -1 charge? It gains 1 electron. -2 means what? They gain 2 electrons. Or why it is gained 2? Like I already have said, chemical bonding. There are many rules, many factors are there. So all depends upon that particular element's reactivity. Oxide O-2 fix. So nitride N-3. That means it will definitely gain 3 electrons in order to get the stability. Of course, there are many points are there, many exceptions are there, many oxidation numbers are there. That's a completely different thing. Now you have to remember all these charges according to their valency. So these are the list of common anions. Here, the difference between cations and anions is names. So cations, general names are coming from their element, more complete name. But here, for anions, you have to remember IDE. The name should end with IDE. If that non-metal, if it is combines with oxygen, you can get the respective 8 or 8. You can check in the slide. Oxide, yes sir, it's not oxygen ion, oxide. It's not nitrogen ion, it is nitride. These basic simple differences you should get the clarity about. And peroxide, superoxide depends upon the number of oxygens and the type of charge. We have different type of anions also only in oxygen, depends upon the bonding. Sulfate, sulfite. Remember, every time when a non-metal combines with oxygen, the general radical is called as 8, SO4 minus 2 is sulfate. It's end with ATE. And when it will get 8, you know students, it will get 8 when the particular sulfate, if the sulfite formula is one oxygen less than the sulfate. Look at what is sulfate formula, SO4 minus 2. What is sulfite formula? SO3 minus 2. That means this is one oxygen less than the respective 8. Those not only for sulfate, anywhere you can check. Nitrate, nitrite, phosphate, phosphite. Like that, everywhere it is chlorate, chloride, bromate, bromate. Like everywhere it is one oxygen less than the respective 8. So like this, these differences, based on the differences, you can remember all the names of the ions: bromide, chloride, chlorate, chlor. You can check chlorate, chlorite. Chlorate is ClO3 minus. Chlorite is ClO2 minus, one oxygen lesser, not like that. Based on the difference, you have to remember all these anions also. So remembering cations and anions, there is a use, that use I'll discuss by the end of the video. So chemical formula, ultimately students, now this is the time. Well, you have seen all the list of cations and anions. Yes, sir, student, these are cations, these are anions. So answer, all these ions, do they exist freely, independently in the nature? Freely means like sodium ion. Can we expect sodium ion in the air, in the atmosphere, roaming here and there, moving freely? Sodium, no. H plus ion, does it exist in the nature? No. Chloride ion, does it exist in the nature? No. Oxide ion, no. The answer is all these ions, either whether cations or anions, they do not exist independently in the nature, freely. Independently meaning freely. Then how do they exist? Always they exist in the combined form, and they form a compound, and this compound, to represent in a shortcut, is called as chemical formula. For example, sodium ion, chloride ion, yes or no? Does sodium ion exist in the nature? No. Chloride ion exist in the nature freely? No. They combine and they exist as sodium chloride, and definitely we have to write a shortcut representation or not. So that shortcut representation is called as chemical formula. What is symbol? The shortcut for element is symbol. What is chemical formula? The shortcut for molecule is chemical formula, or a compound is chemical formula, students. So both are same, molecular compound, both are same. So short form representation of a molecule substance is known as its formula. What is the formula of water? H2O. Yes or no? Water. Two hydrogens combines with oxygen. So how can we represent these formulas? Ultimately the molecules are made up of atoms only. That means we need to represent the symbols only. Yes or no, students? H2O we are saying, H and O we are saying. What is this number 2? What is this number 2? What does it indicate? It indicates atomicity, we discussed in the previous video. Number of atoms in a molecule. So what is chemical formula? How can we represent a chemical formula? A chemical formula is a shortcut representation of a molecule or a compound using symbols and subscript numbers. What does the symbols indicate? The element present in the molecule. What is the subscript number indicates? How many atoms of that element present in the molecule? Yes or no? H2O. What we can understand from this? 2 hydrogens and 1 oxygen present. 2 belongs to hydrogen, 1 belongs to oxygen element. Got the clarity? Carbon dioxide. What is the formula? CO2. 1 carbon, 2 oxygens are present. 1 carbon element is there and other oxygen element is there, which are 2 atoms of oxygen are present. Got the clarity? That is formula. So example, H2. H2 denotes one molecule of hydrogen containing 2 atoms in combination. These subscript numbers indicates the number of atoms in a molecule. That means they are combined. P4 denotes one molecule of phosphorus. Yes, sir, no, this is one molecule only. But what is this 4 indicates? Number of atoms present in that one molecule. Right. Next, formula of the compound the same. The symbolic representation of one molecule of a compound by the number of atoms of various elements present in it is called as formula of a compound. Example, the formula of calcium carbonate is CaCO3. Calcium carbonate CaCO3. So what we can understand by this formula? We can understand there is one calcium, one carbon and 3 oxygens which are chemically combined to produce how many molecules? One molecule only, students. In one molecule we have one calcium atom. There is no number in general. If there is no number in general, one calcium. There is no number for carbon also, one carbon, and there is number 3 for oxygen. What does it mean? 3 oxygens all together combined to produce a molecule called as calcium carbonate. So following information is given by the formula of a compound. So what we can able to understand by this formula, it tells which elements are present in a compound. Obviously, for example, the previous example CaCO3, which elements are there? Calcium is there, carbon is there, oxygen is there. Of course 3 are there, but in general both are, all the 3 are oxygen elements, same type, students. 3 elements are there: carbon, calcium, oxygen. That information, it tells the number of atoms of each element present in a compound. Yes, correct. Look at here, calcium one element, and carbon one atom, and oxygen element how many? 3. That information also. Got the clarity, students? It tells the element and the number of atoms of that element also. Examples, all these points are very main points. Listen carefully. When the numeral is written before the symbol, it represents the number of atoms in a molecule of that compound. For example, students, for example 2Cl and Cl2. What is the difference? 2Cl and Cl2. What is the difference? First of all, the principal difference is here the number 2 is represented before the chlorine. Yes or no? Before the chlorine atom. Here the number 2 is represented at the bottom side of the chlorine atom. This is subscript position. This is called as coefficient number. You answer whether both these representations are the same or different. What's your answer? Just guess your answer. Okay, the answer is both the representations are not same, they are different. What do they differ by? First of all, this you already know. What is that? Here the number 2 indicates number of atoms in a molecule. Yes or no? This is chlorine is one molecule, and how many chlorines are there in that one molecule? 2 chlorine atoms are there. Like chlorine bonds with chlorine, it forms one molecule. That is Cl2. Then what is 2Cl indicates? 2Cl also indicates 2 chlorine, students, but are they bonded? No, that is the difference. Here chlorine indicates, 2Cl indicates chlorine and chlorine, that's it. Is there any bond between chlorine and chlorine? No, that is the difference. Subscript number indicates number of atoms in a molecule, but the coefficient number indicates only number of atoms. If it is an atom, if we are representing molecule, that coefficient number indicates number of molecules. I'll give those examples also. First of all, you got this clarity. What is the difference? Subscript number means number of atoms in a molecule. Is it possible? Can we change this number like Cl3? No, already 2 chlorines are attached. That is fixed. You cannot change that number. Can we change this number? 2Cl? Yes, we can change. We can take 10Cl also, you can take 30Cl also, we can take any number of chlorine atoms. Yes or no? We are not changing the molecule, we are not changing the atom. Yes or no? We are simply taking the more number of atoms, that's it. Are we changing the property of the atom? No, we are not changing that. Got the clarity, students? Right. So students, next what we have is here. So when we write 2S, 3Cl or 4Al, it means 2 atoms of sulfur, 3 atoms of chlorine, 4 atoms of aluminum. That's it. Not in a molecule. Why? Because they are not molecules. Yes or no? When we write 2NaCl, now answer, what does it mean? 2NaCl. What's the meaning of 2NaCl? First of all, the meaning of this is, students, 2NaCl means NaCl and NaCl. That's it. 2 sodium chloride molecules. Yes or no? 10 NaCl means 10 NaCl molecules. Got the clarity? The number, coefficient number in front of the molecule indicates number of molecules. In front of an atom becomes the number of atoms. That's it. Got the clarity? Now, how many sodiums are there? Here there is one sodium. Here there is one sodium. The total how many sodium? 2 sodiums are there. And how many chlorines? 1 chlorine here, 1 chlorine here. How many chlorines total? 2 chlorines. So this number 2, many students will do the mistake here. This number 2 not only applied for sodium, this number 2 also applied for chlorine, not independently as a whole. 2 NaCl. Understood, students? 2 sodium chloride molecules. In every sodium chloride molecule, there is one sodium, one chlorine. In 2 molecules means 2 sodiums, 2 chlorines. In 10 molecules means 10 sodium, 10 chlorine. That is the point. So, right, clear? So, like next we have other examples also. You can check 4ZnO. What is the meaning of 4ZnO? 4 zinc oxide molecules. Yes or no? How many atoms are there? 4 zinc atoms are there, 4 oxygen atoms are there. Next, this slide also, when a numeral is written on the right bottom side of the symbol, it indicates number of atoms in one molecule. This point we already discussed. H2 means what? 2, not just 2 atoms. You have to say 2 atoms in one molecule, in a molecule. O2, 2 atoms in a molecule. Yes sir, SO2, what is the meaning? There is one sulfur and 2 oxygen atoms in a molecule. Al2SO4 taken thrice. Al2SO4 taken thrice. What is the meaning of this, students? Al2 means what? How many aluminiums are there? 2 aluminiums are there. SO4 taken thrice. SO4 taken thrice. What is the meaning? This 3 is applied for whole SO3. That means SO3, SO4, SO4 and SO4. 3 are there. Got the clarity? This 3 is applied for sulfur as well as oxygen also. How many sulfurs are there? 3 sulfurs. 1, 2, 3. Yes or no? SO4. How many oxygens are there? 3 4s are 12. That's it. 4 here, 4 here, 4 here. 4 plus 4 plus 4. How much total? 12. So, ultimately they indicates number of atoms. If it is in brackets, you have to multiply with that number. So, when we write 3KNO3, now you have to answer this. 3KNO3. First, what is this number 3 indicates? Number of molecules. Is this number 3 is only applied for potassium? No, the whole molecule. What is the molecule? KNO3 is a molecule. How many potassium? In general, in one molecule, how many potassiums? 1 potassium, 1 nitrogen, 3 oxygens. Now multiply with 3. You will get 3 potassiums, 3 nitrogens, 3 3s are 9 oxygen atoms. Got the clarity? The coefficient number indicates number of molecules. The subscript number indicates number of atoms in one molecule. Students, right? So, how to write the formula? So, we already have discussed about the cations and anions, right? So, the reason why do they combine is because, students, cations, what is the charge? Positive. Anions, what is the charge? Negative. These positive and negative charges are the reason why they are highly reactive and ultimately they want to get neutralized. Main point. Why they are combining? In order to neutralize the charge. If plus 1 is there, how it can neutralize? If we add minus 1, plus 1 minus 1 equal to 0. If plus 2 is there, you can add minus 2. Plus 2 minus 2 equal to 0. That's what the concept here. So, Al plus 3. Look at the compound. What is the formula? AlCl3, aluminium chloride. What is the charge on aluminium, students? Look at here. Plus 3. It is combining with how many chlorines? 3 chlorines. Chloride charge is how much? Minus 1, minus 1, minus 1. Minus 1, minus 1, minus 1. How much altogether? Minus 3. Minus 3 plus 3. 0. Got the clarity? Why they are combining in a particular ratio? In order to neutralize. What is the formula of sodium chloride? NaCl only. Why? Because sodium is plus 1, chloride is minus 1. 1:1 ratio. Magnesium chloride. What is the charge? MgCl2. Why MgCl2? Why? Because on magnesium, what is the charge, students? Plus 2. On chloride, minus 1. Now you answer what ratio they need to combine in order to form a neutralized compound? Mg plus 2. Cl minus 1. How they can combine? Can we change this minus 2? No, I told you clearly, you cannot change the charge. So how to combine? 1 magnesium needs 2 chlorines, that's simple. Minus 1, how much? Minus 2. Minus 2 plus 2, 0. What is the formula? MgCl2. We have one shortcut. That shortcut technique is called as crisscross method, students. Crisscross method. What is crisscross method is, by writing the ions, opposite ions, the charge number, you can see here, what is the charge number on aluminium? 3. It will become subscript number of the opposite element for chlorine. What is the charge number on chlorine? 1. It will become subscript number for aluminium. Of course, 1 we don't represent in general. Look at the formula. AlCl3. That's it. I'll give few more examples like magnesium chloride, the same example. Mg plus 2. Cl minus. According to the crisscross method, write the formula. Mg. Okay. What is opposite ion charge? 1. We don't represent 1. Next, write chlorine. What is opposite ion charge number? 2. That's it. That will become subscript number of this element. Got the clarity? MgCl. Last example, students. Let us practice magnesium oxide. Magnesium oxide. What is magnesium ion? Same again. Mg plus 2. What is oxide? O minus 2. Now you answer. What is the formula? If anyone thinking Mg2O2, that is absolutely wrong. Why? Because they will combine in simplest ratio. What is the ratio here? Charge number 2. What is the ratio charge number 2? 2:2 means what is the simplest ratio? 1:1. Yes or no? Practically, think practically. One magnesium ion charge +2, one oxide ion charge -2. They can neutralize in a 1:1 ratio or not? One ion can satisfy one oxide ion or not? One magnesium can neutralize one oxide ion or not? That's what the same. They combine in 1:1 ratio and the formula is MgO. That's it, directly. That means you have to remember, while practicing this crisscross technique, you have to remember that these ions combine in by simplest ratio, opposite charges only, simplest ratio. If both here 3 is there, then what is the ratio they will combine? 1:1. Yes or no? Here 2, here 3 is there, then the same 3 here, 2 here. That is crisscross technique. All these ions, they do not exist independently, students. How do they exist? They exist in the combined form. And how do they combine? Do positive combine? No. Do negative combine? No. How it can be neutralized? A positive combines with respective number of negatives. Ultimately, the overall charge will be 0. Are we writing any charge on sodium chloride? It is a neutral compound. That's a concept about ions and how do they combine, why do they combine, and the names also. So that's all, students, about the radicals in this chapter. We have one more episode, one more video left for this concept called as language of chemistry, that we'll discuss in the next video. Thank you.